Hello everyone, welcome to the ABB RobotStudio tutorial. In this video, we will learn how to write a simple code. I will explain you how to write a simple code by using the teach pendant and how to write a simple code by using the rapid environment. The rapid programming environment is a very powerful programming environment for coding robotic operations and different tasks. Okay, so the code that we will create will perform the following task. The robot will start from some safe position, for example from the position over here. Then it will go to the corner of this cube. Then it will go to some point over here, then to the point over here, then to the point on the other edge of the cube and back to the corner of the cube, and finally the program will make the end effector to go to the safe position. So let's see how to do that. Now, the situation that you can see over here, or the scene that you can see over here consisting of a cube and of the robot, is made in one of my previous tutorials. A link to this tutorial is given in description below. Moreover, in that tutorial, I have defined a tool frame that is located over here at the tip of this conical end effector, and I have defined basically a work object that is being located over here. That is the center of the work object of the coordinate of the zero coordinate of the work object is located over here. The x-axis is in this direction along this edge of the cube, and the y-axis is along this direction, another edge of the cube, and the z-axis is perpendicular to this top plane of the cube. And I will use this tool frame and this work object to demonstrate rapid programming. Okay, so let's start. Let's close these windows. And the first step is basically to define our rob target points. How to do that? I will click over here, and over here I cannot see the data type corresponding to points. So I need to click on View, All Data Types, and over here I need to find rob target. So let's find this option. So here you need to scroll down. Rob joint, here is the rob target. So I'll double click. And so let us define our points. So let us first define the safe point. So I'll click on New. I'll call this safe position. And I will leave these other parameters. I will just leave their default value. So the scope should be global, the storage type should be constant, task T rob1, and I will click on OK. So what happens right now? I have recorded this position. Okay, but here you should be very careful, because this position is defined relatively with respect to certain coordinate system. And in order to figure out the coordinate system, you click here on the jogging menu, and you will see that the tool is the end effector, meaning that we are tracking this point over here. These are the coordinates, and the coordinates are defined with respect to a work object. So the coordinate system relative to which this point is defined is the work object coordinate system. Okay, now let us verify that for a second. So I'm going to jog my robot or the end effector to this point, to 0, 0 point. So I will have to decrease z. Okay, I'm decreasing z. Okay, z should be, okay, let's say approximately 0. Let us decrease y, and let us increase or decrease, actually increase x. Let's see where is our 0 point. Okay, so here is our 0 point, approximately over here. And while jogging, I was in the motion mode. My motion mode was linear motion mode, right? This is very important. Now, to verify that I have correctly defined my point, I can do the following. I can basically go to the jogging menu and I can click on go to. And if I click over here, save position, I should go to my point, and I should click and keep my left button clicked, press, go to. So here's my save position. Okay. I click on close. Now, let us see what happens if for some reason someone pressed over here, change the coordinate system, place, for example, a base coordinate system, and changed even a tool frame, place tool 0. Tool 0 is the center of the faceplate. And let's see what happens if I go to save position. Let's see what happens. Aha. I didn't reach the point that I defined. Why? Because now the point is defined relatively to the base coordinate system. And moreover, you're not tracking anymore the tip of the end effector, you're basically tracking the center of the faceplate. You should be very careful about this, and you will see later on, once we write a code, that it's very important to specify the tool frame and work object. So let us bring back our tool frame, the end effector tool frame, and the work object should be cube. And let us basically specify here that we basically move in the work object, and I click on OK. So let us go to our save position, and if I press my left mouse button and if I keep it pressed, I will go to my save position. Okay, so I will close this menu. Okay, next we define other 4 points. Again, I click over here, I click on the program data, I click on drop target, and I click a new point. I will call point 1, and I click on OK. Now I can manually specify the coordinates of this point because it's going to be the corner of the cube. It's going to be 0, 0, 0. But here you should be careful. Again, we're living in the work object coordinate system where the center is over here, x-axis is along this direction, and y-axis is along this direction, and I click on OK. Okay, let's verify this point. You can basically go back to the jogging menu, and then you can go to, let's go to the point 1, and let's do go to. Okay, perfect. This is the point 1, close. Let's define other points. I click on program data, then I can just copy this point. Copy. I will call the point P2. And let's define this point. Let this point be x 150, or let's say 100. And let x, y, and z be 0, 0, 0. And I click OK. Let's define the third point. This is not what I want. I need to copy P3. Let's change the coordinates of this point. So y will be here 100, x will be 100, and this will be okay. Let's define the fourth point. Again, copy P4. the coordinates of P4 points will be 0, 100, 0, okay, and okay. So let us verify these points. Let us go to the point P2, go here, jogging menu, go to, and we go to the point P2. Okay, here's the point P2. Let us go to the point P3, now point P4, and let's go back to the point P1. Perfect. We have basically our 4 points. The next step is to write the code. I will close this menu. Again, I will click over here and I will click on Program Editor. Okay, so here is my Program Editor. And here I can add a code. To add instruction, a moving instruction, I will click over here and I will select an option. So the options that I want to consider are actually move J and move L. Move L is move linearly from point to point, and this move J is the movement in the joint mode. So I will select move L. And then we have this question: do you want to insert the instruction above or below the current selection? 1, I will select above. So here is my command. Let's close this menu, and here it is. You can notice that this is a template, and basically what is very interesting over here is that this star here represents an arbitrary point. So to change the value of the point, I will click over here and I will select my point. Let the first point be the safe position. So here's my instruction. I will move from the starting point can be anywhere, to my safe position point with velocity v1000 with this parameter z50 that I will explain in one of my future videos. And what is very important over here is that the ABB programming environment automatically selects the tool frame. So this is our tool frame, it's the end effector tool frame, and the work object is equal to cube. So this is very important, and if, for example, over here I had a base frame or some other work object, that is, if these options were activated, then in my program I will see that tool frame and that work object over here. So it's very important when you manually enter your code is that the proper work object tool frame are being selected. That is, that the proper tool frames and work objects are being activated. If this doesn't happen, that is, if, for example, you had a different work object or different tool frame, over here you will see different values and you might crash your robot in practice. It is very difficult to write the code and to debug the code by using this teach pendant, especially if your code has 50 or 100 code lines. Now, luckily, ABB RobotStudio has a programming environment called Rapid. To activate the Rapid, you will click over here, and then over here you need to select the option Set Program Pointer to Main in All Tasks. And then you have this menu, right? And then what you need to do is to click over here, go to the program, basically pointer. So if you go to the program pointer, you will bring this menu. So this menu over here brings our rapid code. And the first thing that you can notice is that at the beginning of your program, you have some definitions. So these first two code lines represent our tool data and work object data. So in my previous video, I have defined an end effector, and I have manually defined the end effector. That is, I have jog the robot to certain position, I have attached my end effector, I have basically displaced my coordinate system from tool 0 to end effector coordinate system. But basically in the rapid code, this can be done by one code line. Similarly, the work object representing basically the coordinate system where the 0 is located at one of the basically edge points of the cube is represented by this code line. And here are our points. This is basically the save position points. These are the coordinates of this point, save position. Now, what is very important to observe over here, here we didn't define a coordinate system that this point is relative to, right? This is not being defined over here. It will be defined later in the code. This is our point P1, P2, P3, and P4. So these are our points, right? This is usually at the top of the code. And here is our main function. Main function is the main function from where your code starts. That's why it's called main. And so here is our movement instruction. So move L to save position with velocity with the zone 50. And over here, we basically specify the work object and the tool frame. End effector is the tool frame. And here's our work object. So let us add additional code lines since we want to move to certain points. So what I will do, this will be the save position. This will be the point 1. Then I go to the point 2. Then I go to the point 3. Then to the point 4. And then I go back to point 1. And then I go back to my save position. So here is our code. Once I'm finished with writing the code, I need to apply the changes, because if I go back to my end effect, to my basically teach pendant, I don't see these changes over here. I can only see the first instruction that's being shown over here. So I need to click over here, apply, and apply all. So if I go back to my teach pendant, I can see my code over here. So if I click over here, here's my code, right? So all the changes that are made over here can be reflected on your teach pendant menu by simply clicking apply and apply all. So for example, if I change something over here, I can click apply all. Okay, this is just an empty line. It's not going to affect our code. Okay, so let's go back to our simulation menu and let's run the code. Now, to run the code, first of all, let us close all these windows. Now, we need to again to activate our controller by clicking over here, and operating mode, we need to go back to the manual operating mode and we need to click enable device. So let's go back to our simulation. Let's bring our program. So here's our program. And the first step is to bring the pointer at the top of our main function. So I will click debug, pp to main. Now my pointer is at the beginning over here, although previously it was also at the beginning. However, you might start your code from somewhere over here, and that's not possible. You always have to bring it to the beginning of your main function. And let us run the code. So to run the code, we'll simply press this button and let's see what happens. Okay, we go to 0 point, we go back, and we go over here. Again, we go describe square, and we go back. Notice, that is, if you carefully observe the motion of the robot, you will notice that we don't describe an exact square. We describe a square with oblique edges. That is, not oblique edges. The points are not basically points. The points are approximated by circles. That is, the edge points are approximated by circles. And this is a direct consequence of the fact that you have Z50. This Z50 means that we basically approach our point, not exactly, but within some circle with a radius of 50. Okay, that would be all for today. I hope that you like this video. If you like the videos I make, please subscribe or support my channel. Thank you very much and have a nice day.